Hi everybody, my name's Devin, and this is Project 2. So we can take a look at temperature sensor here. I used this DHT11 temperature sensor, so it's temperature and relative humidity sensor actually, but we're just going to be looking at temperature. So there it is. So it's pretty simple, it has 3 pins, and if we take a look at the circuitry, I have the black wire as ground, the red wire is the VCC, and the blue wire is the signal. So that's where we actually read the temperature data from. So we have those hooked up. So row 15 is the ground, so that's going to be connected to the ground pin on the Arduino. The row 16, so the middle pin of the sensor, is going to be hooked up to the red jumper wire, and that goes to the 5-volt pin. And then the blue wire, it's hooked up from pin 9, digital pin 9 on the Arduino, to row 17, and then hooked up to the signal pin of the sensor. So there it is. That's pretty much it. A little more simple than last time. And then the other thing that I did is I just wrote a Python script to run on the host machine. So it's gonna, I can talk a little bit more about this later, but it captures the serial data, prints it, and then it does some other stuff too. So I'm gonna start this. So it's gonna start waiting for a serial connection, and then I'm gonna put this down for a second. Let's see, okay. And then I'm gonna come over here and get rid of this. So that script is just going to wait until it gets a connection. Then as soon as the connection's formed, it's going to start reading from the temperature sensor. So take another look at the screen. So I have this taking a reading every 10 seconds. So to talk a little bit about my design, I used the timer 1 functionality on the Arduino, so I'm using that to generate my interrupt. So every 2 seconds that timer is going to be generating an interrupt, and then in my interrupt service routine I basically have a counter that's going to keep track of the consecutive interrupts, and then on every 5th interrupt, so 2 seconds each interrupt every 5 times, so that'll be give us that 10-second sampling interval. Every 5th interrupt, it resets that counter, and then it flips just a Boolean flag, an update flag, to true. And that's all it does. And then for my task code, every time the Arduino is going through its loop, it just checks that update flag, and if it's true, it goes through, it takes the current time, so it does that by using the millis function. So it basically just takes the number of milliseconds that since the Arduino powered up, and then it takes the reading, the current temperature off the sensor in degrees Celsius, converts that to Fahrenheit, and then sends that over the serial bus in a comma separated tuple, so time, comma, temperature. And then it resets that update flag, and it does everything again. So then it waits. And that's pretty much it. So if we take another look here, so this has been running. Pretty stable now. There was one little outlier there, but around 66.2 degrees Fahrenheit. And yeah, so now instead of putting it in the fridge, I have my lunchbox here. It's clean, and I've had it in the freezer, and I have some ice packs in there, so I figured that's going to be good enough. So I'm just kind of going to put the stuff in there and zip it up, and then that'll give us that difference. So I'm going to do that now. Let's see. I did this the other day. I'm just going to throw it in there. And then I'm just gonna zip this up. Keep it nice and cool in there. It's good enough. So there you have it. My temperature sensor is nice and cool in my lunchbox. And then we can take a look. So let's see if it starts. We should see it start going down a little bit. Okay. 64. 62. Yep, so it's going down. We'll see one more sample and then we'll let it sit there for 5 minutes and we'll take another look. Another 62. Let's see it go down. Come on. 60.8. So it's cooling up. So it's in there. So we'll wait 5 minutes and we'll take another look.
5 minutes later.
Okay, we're back. So it's been about 5 minutes. So if you see, I just took this out and got down to about 42.8 degrees Fahrenheit. So it got pretty cold in there. I've had that in the freezer for like 2 days now. So it's pretty chilly in there. Yeah, so it took a bunch of samples. I think, yeah, so if you look up here about 1720, 1720, we started going down. So about 5 minutes later, 520 hit 42.8. Now took it out back to room temperature. Now it's going back up. So 44, 46, 48. Yeah. So I'll let this sit for 5 minutes now. And then when we come back, I can explain my script a little more. And then we can take a look at the results. Cool. See you in 5 minutes.
5 minutes later.
Hello. Okay, so part 3. So we sat out room temperature again for 5 minutes. So we're still plugging along. Got back up to 60 degrees. So it's climbing back up. And now we can take a look at the results. So what I have for this script is basically it's just listening on the serial bus, and it's processing the sample that is sent from the Arduino every 10 seconds with the time in milliseconds and startup and the temperature. So what I do here is I just print that out to the screen. But before I do that, I have I'm converting it in Python to take that milliseconds and convert it into a time of day so we can get a little better visibility on the actual time, a little more user readable. And what I do there is right when the board comes up, I just send a serial message over to the script, and then assuming we've started the script before connecting the Arduino, that it just takes that very first message and it captures the current time, and it uses that as its baseline. And then every message that gets sent after that with the milliseconds and startup, it just takes that starting time and then it adds those milliseconds on to get an estimate time. So it's not perfect, but I think it's like maybe 1 second off or something, but I think it's good enough. Yeah. And then the other thing is what the script does is I can send it signals. So if I do a Control C, it's as it's processing each one of these samples, it's just storing them in a list as well. And so I hit Control C, so it exports it to a CSV, and then it keeps, processing the rest. So I'll put that CSV in with the zip file, my submission, and then, yeah. And that has, sorry, my cat just scratched me, so I got distracted. But yeah, so the CSV, that just has comma separated values with the millisecond, that raw millisecond time and the temperature. And then the other thing I have here is that, put it down for 2 seconds. So when I close this, I can send it a Control Z. It's going to stop listening, and then it's going to bring up a plot. So I did it this way instead of copy and pasting it into a spreadsheet program. In theory, I could take that CSV export that I generated and do that same thing, but the graph would look exactly the same as it does here. So I have my temperature readings with the start time. So it started about 4:56, 4:57, and then it's plotting the temperature in degrees Fahrenheit versus time. So we have that first about 4 minutes where we were kind of talking and explaining the design, and then we put it in the lunchbox and it started going down. So that was about I think 17. I think it was like 5 o'clock. We put it in the lunchbox, and then we waited our 5 minutes. So at 17, so at 5:06, we hit our bottom here. So that was about, I forget what it was, 42.8 I think was the lowest we hit. Then we took it out back to room temperature for another 5 minutes, and it climbed back up, back to around 60. So, and I think, 62.8 is where it got up to when we stopped. And that's it. So, thanks for listening, and let me know if you have any questions or comments or anything, and we'll see you for Project 3. Thanks.